Understand the definition of pH and neutrality. The pH of a solution is defined by the mathematical relationship pH equals log H to the power plus. A solution is chemically neutral if and only if the concentration of hydronium ions equals the concentration of hydroxide ions. H to the power plus equals OH to the power negative. At the standard reference temperature of 25 degrees Celsius, pure water has H to the power plus equals 1.0 times 10 to the power minus 7 molar, which yields a neutral pH equals 7.0. Analyze the chemical equation for water autoionization. Water molecules naturally undergo self-ionization to a very small extent. H2O plus H2O is in equilibrium with H3O to the power plus OH to the power negative quad delta H greater than 0. This chemical process is endothermic, delta H greater than 0, because it requires a substantial input of energy to break strong covalent OH bonds in order to separate the neutral water molecules into charged ions. Apply Le Chatelier's principle to temperature changes. According to Le Chatelier's principle, if a system at equilibrium is subjected to an increase in temperature, the equilibrium will shift to counteract that disturbance by favoring the endothermic, forward, direction to absorb the excess thermal energy. Determine the effect on the equilibrium constant, Kw. Because the autoionization of water is endothermic, raising the temperature from 25 degrees Celsius to 37 degrees Celsius drives the equilibrium forward, causing water to dissociate to a greater extent. This mathematically increases the value of the autoionization constant, Kw equals H to the power plus OH to the power negative, from 1.0 times 10 to the power minus 14 at 25 degrees Celsius to approximately 2.4 times 10 to the power minus 14 at 37 degrees Celsius. Relate the larger Kw to the lower pH of 6.8. Since water always autoionizes in a 1-to-1 stoichiometric ratio, the concentrations of hydronium and hydroxide remain equal. H to the power plus equals OH to the power negative equals square root of Kw at 37 degrees Celsius. Because Kw is larger, the concentration of H to the power plus must also be larger. H to the power plus equals square root of 2.4 times 10 to the power minus 14, approximately 1.55 times 10 to the power minus 7 molar quad, which is greater than 1.0 times 10 to the power minus 7 molar. Because H to the power plus has increased, the negative log calculation results in a lower pH. pH equals log 1.55 times 10 to the power minus 7, approximately 6.8. Therefore, option B is the correct explanation. The correct answer is option B. At 37 degrees Celsius, the autoionization constant for water, Kw, is larger than it is at 25 degrees Celsius.